Hello and welcome to CIMAC Tech-Talks web event titled The Fuels of Today Leading into Tomorrow. It's organized this time by CIMAC Working Group 7. My name is Kjeld. I'm chair of the CIMAC Fuel Oil Working Group and I'm director of new technologies in our promotion department here in MAN Energy Solutions. My co-host today is Charlotte Rojgaard. She's the secretary in the CIMAC Working Group Fuels and a global head marine fuel services in Veritas. First, a little intro to the tech calls and to CIMAC. CIMAC Tech Calls is a new format for live discussions offering fresh insight into important topics of the industry. The Tech Talks is organized as an informal discussion session, usually 60 to 90 minutes long on different topics, aiming to provide a common understanding on the topic that will be relevant for the industry as a whole going forward. The sessions will be live event with an audience, web-based or face-to-face, comprising an expert guests panel, who I will introduce also a little bit later. Afterwards, we will have a Q&A session. So, for you who don't know that much about CIMAC, I can inform that CIMAC is one of the leading industry associations that brings together the large energy engine community, by extension the shipping and maritime industry together for scientific and technology exchange on common important topics. We are a global non-profit organization consisting of members from 27 countries worldwide with 11 working groups and 2 strategy groups offering a forum for discussion on common issues affecting the industry. A little bit of some household rules at the start. As audience, you can post your questions in the chat window. This will be taken up during the Q&A rounds after the panel. We will try our best to answer as many questions as possible. The event will take today 90 minutes and will be recorded. Afterwards, you can see the recording on the website of CIMAC. Coming back to the agenda, we have 2 subjects today. We have the status for very low sulfur fuel oil and the use of biofuels in marine. For the first subjects, what can we conclude about the use of very low sulfur fuel oil and ultra low sulfur fuel oil based on service experience, including quality, stability, compatibility, among others, that will be presented by Charlotte. Afterwards, a small Q&A we will have on this subject only. Then the second subject, main subject, is presentation and panel on biofuels in marine, where we will have all the panelists presenting the different aspects, applications and uptake of biofuels. We see in the interest a huge increase in interest for utilizing biofuels, and of course, as CIMAC Working Group Fuels, we are also very much into that and have built up a subgroup taking care of that, following what happens, so we are able to give guidelines and recommendations. So, presentation of the panel on biofuels in marine. We will have different panelists. We will have Dax van Diepen, Maersk Oil Trading. He is a senior quality manager for Maersk Oil Trading. He will cover the subject how to define the biofuels. Then we have Juoperi. He's a chief expert in Wärtsilä, research and design organization, and have this responsibilities and fuels and loops and cooling water additives and so on. He will cover the subject use of biofuels in marine applications. Then we will have Remco de Witte, global application manager from Alfa Laval. He will cover application and treatment of the biofuel on board. And last but not least, we have Unni, Einemo, who is a director for International Bunker Industry Association, IBIA, who will cover Knox compliance and Einemo clearance for the use of biofuel. So a short introduction to CIMAC Working Group 7, the fuel oil. What we do here is we make recommendations and tools for the industry. We look at low sulfur fuel quality operation, and we will continue to do so, even though you could say now a year and a half have gone with the very low sulfur and ultra low sulfur fuel. We will constantly, of course, monitor what is happening and come up with recommendations based on that. Combustion properties, fuel grade rationalizations, biofuels considerations, as we talked about, follow fuel quality worldwide. We have in the group a lot of analysis institute for fuels, and they can give us quite a very, very important, you can say, database for what is happening with the different content in the different fuels. Investigation and prerequisites for using fuel from different compositions. We are 36 members. We have, unfortunately, it's necessary to have a waiting list. We are not able to be so many as we wanted to be. It will not be practical, and it will not be an easy way to have a recommendation made and so on. We need to be efficient, but we are represented by refiners, suppliers, OEMs like ourselves and MAN, ship operators, fuel testing labs, classification societies, and others. So it's a group of specialists taking care of these recommendations and tools for the industry. We work very closely with ISO 8.7, making the standards for fuel oil, and there many of us is actually represented there also. We have made, we make a lot of guidelines and publications, and without saying more, I would like to give the word to Charlotte. If you would like to have more information about what we recommend in our tools, please go to the CIMAC website. So I will pass the presentation here and go to you, Charlotte.
Thank you very much, Kjeld. Now let me see if I can show my screen here. Kjeld, can you confirm you can see my screen?
I can see your screen, yes.
Perfect, thank you very much. So let's just take a look at the status of the VLSFOs, which is the primary fuel of choice at the moment in the industry. So if we look at the sample distribution that we get into our lab, almost half is now VLSFOs, with a third being gas oils, with 10% being high sulfur fuel oil and a tiny percentage of the ultra low sulfur fuel oils. We can also take a further look at how the, let me see if I move that one. So we also take a further look at how the samples are distributed. When we look at the specification comparison of these fuels. I hope you don't see me in front of everything here because I do on my screen. But we can also see that if we look at how many samples exceed the spec limit, it's around 5% for the two majority of samples we get, the MGDOs and the VLSFOs. Around 5% exceeds the spec. For the VLSFOs, it's around 2% that actually exceeds the reproducibility, and you can claim as being truly off spec. Furthermore, if we dig down and look at it by parameters, which parameters is actually exceeded? Again, we need to split it between the 95% confidence interval and where you can truly say that the samples is out of spec. So for the 95% confidence interval for the gas oil and the ultra low sulfur fuels, it primarily the cold flow properties. For the VLSFOs, it's a little more diverse. So we have sulfur, we have sediment, we have flash point, and we have pour point. For the high sulfur fuels, there is a very clear trend that viscosity is the parameter that is in the 95% confidence interval, the more. On the out of spec, it's slightly different, and I will just focus on the VLSFOs here. Here, it's water followed by sediment and sulfur again. So these are the parameters that we find more of the VLSFOs out of spec on. We could also look into how the averages and the ranges of these new products is, and we see the picture we also saw last year. We see that viscosity and density on average for VLSFOs is below of what it is for the high sulfur fuels. We also see a very large variety, a very large range of viscosities for these new products. The ranges from 3.8 centistoke, which is like a distillate, and all the way up to the highest grades in the ISO 8217 specification, the RMK 700, with a max of 650 almost on the viscosity. We can also look at the cat fines. There's been a lot of discussions about cat fines before 2020, and we could see that the average level of cat fines in these new fuels is same level as for the high sulfur fuel oil. But we also see, and we will get back to that later on, that we go all the way up to some very high cat fines level of 176 ppm. What is important to note here is that the separators can easily remove the cat fines from these new fuels compared to the traditional fuels, because the average viscosity and density is lower than what we have been used to in the past. And we can also see that there are a higher percentage of VLSFOs that has a higher pour point compared to the traditional fuels. 24% of the tested VLSFOs have a pour point exceeding 21. They are still within spec up to 30 degrees on the pour point, but we have a higher portion of the samples that has higher pour points. Also, if we look at the operational reports, because one thing is, of course, whether the fuels meet the spec limits, but it's also a matter of how these fuels perform when we start consuming them. For the VLSFOs, on the operational reports that we issue in the Verifuel team, we have around 50%, half of them, that receive some sort of technical advice or recommendation for the crew to take note of in order to ensure safe operation. So if we look at the samples where we issue an amber alert or a caution, it's on pour point, it's on cat fines, and it's on sediment levels. And then we have those 0.4% of the operation reports that gets a real alert, meaning these are fuels that should be used with extreme caution and may cause difficulties to operation. Here we had a few samples with very high cat fines content, as high as 176 ppm. And we have seen some high sediment level where the samples could not be filtered in the lab because of asphaltenic sludge coming out. So if we just sum up on the operational issues that we have seen throughout 2021, as many as 75% of them are related to filter clogging and separator sludging, asphaltenes coming out of solutions and either unstable fuel at delivery or due to an incompatibility because two fuels has been mixed on board. What is a little different now compared to what we have seen in the past before 2020 is that even low mixing ratios may turn a fuel unstable or due to an incompatibility between these two fuels. The very strong recommendation to avoid experiencing these issues is to keep the fuel segregated, to try to reduce settling and serving tanks level as much as possible before changing over to minimize that mixing that may occur on board. And of course, to manage the temperature very carefully to avoid overheating the fuel, because heat may make this process of the asphaltenes coming out even worse or go faster. And especially to be cautious of thermal oil heating, because the thermal oil heating may generate some very hot spots in around those heating coils. So those are some of the primary recommendations for the industry to be aware of considering the VLSFOs. Overall, I would say that we do not see more cases of operational issues than we saw before, but we do see of those fuels that do cause issues that it's really related to stability or compatibility of the fuels. That was the very short summary I had prepared related to the VLSFOs and the status. If there are any questions, I'm happy to take a couple of questions now, and otherwise we can go back to it during the Q&A later on as well.
Yeah, thank you very much, Charlotte. Any comments? Any questions? I do not see any questions coming up.
Then I suggest we move on to the interesting topic of the biofuels.
Biofuels, yes, let's do that. Dax, are you ready?
Yeah, I'm ready. Can you hear me? Hi.
Yes. Hi.
I think. Can you let me know when you see my screen, please? Can you let me know when you see my screen, please?
Yeah, we cannot see it yet.
Okay. But I changed everything, so.
Mm-hmm. And you have pushed the show screen there? Yeah.
Not yet. I've not seen the share screen button coming in.
Okay.
1 second.
Enerod, can you give Dax the possibility?
Yeah, Dax, can you click on sharing on top?
Mm,
and then show screen.
Yeah. Show screen can.
Yeah.
Okay.
Now we can
Thank
see.
you.
Okay. Thank you very much. And that should be. Can you see it now? Can you see it or?
We see it.
Okay. Well, sorry about that. Took some time, all these new techniques. Thank you for having me. So I was asked to give a short presentation on how to define biofuels. And the first thing that came into my head was take a picture, because a picture say more than 1,000 words. And I think this one was the most appropriate one to actually show the process of biofuels. The sun feeding the crops in the field, and from the crops we produce food, but also the potential of fueling our world. But of course, we cannot live in the Pictionary book, so we also looked at the words. So just some linguistic definitions. So bio comes from the Greek word which means life, and fuel is a substance that is used to provide heat or power. So if you combine those two, then you come to biofuel, which of course is a very broad definition of a biofuel. A biofuel is defined as a fuel made from living things or their waste. That's the Cambridge Dictionary definition. And biomass is the material also from dead plants or animal substances, which is created to create the fuel. What you see in practice is both terms are swapped and used in the same situations. So, for instance, you can use a biomass as a biofuel, and that makes it a bit more difficult to actually use the word as a definition. A good example is, for instance, logs, which you put into your fire, which a log is a biomass, but when you put it into your fire to heat your home, it becomes a biofuel. Then if you look at biodiesel, it's a fuel made from vegetable oils or animal fat. Then okay, you can almost say anything is a biodiesel. If you look into more data from people who use it more frequently, then biodiesel more or less is the equivalent of a FAME, which is a fatty methyl ester produced from biomaterials. But again, it's not a clear definition saying, okay, biodiesel is always a FAME. Then there's also the word that goes around, which is renewable diesel, which is not in the dictionary for that matter. It's actually, I think, more or less a commercial name, and it actually holds the hydro-treated vegetable oils, which on the definition could also fall under biodiesel. Don't forget, there's also other biofuels like a biogasoline, which is something we as diesel people do not always is on top of our head, but it's also produced from biomaterial. The reason for this exercise is basically that I wanted to show there's quite some dispute about how do you actually use which word for which substance to be able to find a biodiesel, but that as a starting point. So where are we today? So today we have the ISO 8217, which defines the fuel that we use on board of our vessels, which is predominantly designed around fossil fuels, and that's also how we use it. But it's good to realize that also already there a part which is actually contains bio material. For instance, in the distillate range, we have the max 7% FAME, which is more or less a copy and paste that is used on the automotive industry. And there's another thing that's not that commonly used, which is actually the description of the feedstock of the fuel, of the material used to produce the fuel, which for this occasion and this specification is predominantly hydrocarbons from petroleum sources. But there already is also the optionality to include some hydrotreated vegetable oils, gas GTL and BTL. Again, it's not something that we currently see much used, but also emphasizes the fact that we need to work on getting some sort of more guidelines for the industry, how to define a biofuel. So the next slide is a short overview to give you an idea about the diversity of feedstock, but also production processes that are used to create a biofuel. The first thing I want to point attention to is that actually a biofuel is actually quite a nice and clean product. If you compare that to what we used to have in the past or what we're having today, which is residual fuel. In turn, if you look at the diversity of the feedstock, first generation, second generation, third generation, you can imagine that all these different feedstock come with their own diversity of materials and potential things we need to take in consideration when we start using these kind of fuels. Secondly, it's important to realize this sheet actually defines it between ethanol, which is a gasoline component, and a diesel, and I leave the gasoline component out of it, but there's a whole industry revolved around creating ethanol. This one is created around the production of FAME, but besides FAME, there is also hydro treating and vegetable oil, which gives you HVO, for example. So there's different processes as well, which can create a biofuel. And the last thing I want to mention on this is that also there's side streams. As I showed the picture before, as a shipping industry, we're used to actually complement other fuel industries by taking that portion which suits us best. And actually, that is something that could happen in the future as well. When you look at these processes, there might be side streams which are more suitable for marine and which cannot be used in automotive, for example, where we can complement each other again in the efficient use of feedstocks. I think the main message is that I think it's going to be hard to generalize everything because there's such a big variety of different components, processes, and streams. So where does it leave us? It leaves us with overlooking, okay, if we take a biofuel, how are we going to evaluate that? And then we need to take in consideration the operational challenges, and I'm sure that my next presenters will give you more insight on that. A good example is seals, for example. If you take FAME, and you go to 100% FAME, you will see that you need to verify if your seals can actually handle that fuel. You need to look at the effect of long-term on the engine. You need to look at storage, long-term storage, but also mixing between products. And another thing is what's the true impact on the environment? What's the NOx emissions, for example? And there's also another presentation, so I will not go into that more details. Another consideration is how do you ensure that the quality of the fuel that you're getting, or the blend for that matter, is actually up to the standard that you need to be able to use it safely on board your vessel. So that means you need to define what's coming into the marine fuel pool, and the biofeed that is going to be entering the pool. You need to define how much are you going to be blending potentially, and you need to define how that end product will look like. Which sounds easy, but if you look at the black fuel that we're using, it's going to be it's more challenging to identify those components. So the current approach that we're taking as an industry is that we look at other industries and see what they already applied, as we've done already in the current standard. So we look at automotive, who is actually using this on for many years now, with ups and downs. In the beginning, I think there were some issues. I think now it's going much better. And they've defined FAME standards. So that's something that we could be using, and we are using today to formulate the fuel for our trials. There's an HVO specification. Then when you have those feedstocks, you actually go to the laboratory and start test blending it and see, okay, what does the product look like? And then you try it on board your vessel. You create a risk matrix, you look at what the risks are, how can you mitigate those? You need to get the required approvals because you're going outside the specified fuel. So you need to go to your flag state, discuss it with your class, which in turn also indicates that you actually need something that is actually setting it and standardizing it so others can use it in the way forward. You work out your test plan and evaluate the test results, and then you can see, okay, is it suitable for use or not? So how to standardize marine biofuel, how to define it is actually basically standardizing it. I think we need to realize there's many unknowns, and that should not be a showstopper. There is a clear need within the industry that we need to continue in that aspect, and that's what we're doing today. Within ISO 8217, there's a focus group on bio currently active, which will make a lot of work to actually start including FAME as a blend component into the residual side of the marine fuels. Adopt the current standard to make that a possibility and to standardize that so everybody can use that in the future. The second stream is also to incorporate different streams. So the other processes that are available, but also side streams from the current FAME process, and see how we can actually get that also certified at some stage into a marine biofuel standard. So actually those can also be used without any additional work around it. And in the effort to actually make marine, as we are today, a complementary part of the fuel mix. And that's basically what I had to say about this. I think questions will come later.
Yes, thank you very much. And we will go on with Kai. Are you ready?
Yes.
Thank you.
Can you see the presentation now?
Yes, we can.
Okay. So also from my side, very good morning, afternoon, evening, wherever you are. So in this presentation, I will talk about the use of biofuels from Wärtsilä perspective. And as known already what Dax mentioned, the spectrum of biofuel is very wide. So I got quite often questions, can biofuels be used in Wärtsilä engines? Normally I have a counter question, what kind of biofuel you are talking about? Because various products are behaving in a different way, and I would say that within our company we have a rather wide extensive of biofuels, not only or not always very long term, but at least short testing and evaluation and investigation. And I would say that quite a big number of biofuels is performing well in our diesel and dual fuel engines. But then we have also seen serious problems with some biofuel qualities, and I would say the worst example goes back to late 90s when we tested in the laboratory a product made from animal fats, and then only within 50 hours the fuel injection equipment was so worn that the engine couldn't be started anymore, and that product has an acid number around 100. So for sure there are products which are not suitable. We have listed here some products which we have tested or which our customers have tested in the field. So what I recall, the first one was cold press rapeseed oil, what we tested already in middle 90s. Then this animal fat I already mentioned. Then there are these higher quality products, paraffinic diesel from synthesizes or hydrotreatment, and then there are blends with fossil diesel, and biodiesel, and it's blend with fossil diesel. Then not actually on the marine applications, but on power plant side, quite big interest was around 20 years ago towards the use of palm oil. So kernel oil or palm stearine or then refined, bleached and deodorized palm oil. Fish oil we have tested, then refined waste cooking oil, and probably there are some other ones which I didn't mention here, but at least something where we have been dealing with. So what we have seen in our discussions, both internally and then what is coming from potential customers or existing customers, it can be indicated that the interest towards the use of biofuels has clearly increased during the latest years. On marine side, I would say that the biggest interest is to use so-called drop-in fuels. So you don't need to do any modifications to the engines, and you can blend those fuels with for fossil fuels. So then we are talking about these hydrotreated vegetable oils and biodiesel. Some customers are more interested about pure biofuel use, and some are then asking or considering that maybe they will use B10, B20, B30. So also the percentage of biocomponent has increased, what we have seen lately. I have listed here some typical questions what we get from customers. One is, for example, that are those fuels miscible with each other, and what are the allowed blending ratios? Then in which engine types the use is allowed? Do we need to do modifications? And then what are the influences on the use of biofuel? Does it influence on scheduled engine overhaul intervals? Will engine component lifetime be shorter or longer? And how is it with engine performance? How is it with emissions? Those are very, very common questions. Since at the moment, I would say that at least what we have seen, biodiesel is the product where the biggest interest exists. So I have listed here pros and cons of biodiesel. So since the fuel is in practice close to sulfur-free, also sulfur oxide emissions are at very low level. And the same is valid for particulate emissions. Sulfur and ash is the main contributors for particulate emissions, and those are at low level. And then what is the whole meaning to use biofuels is to reduce CO2 emissions. Biodiesel mixes well with petroleum diesel. It has a good lubrication properties, and it can be used in the existing engines without modifications. And like we already heard from previous presentation, there are also international standards available, which are of course good that the quality is then specified. Then going to the negative things. I think the first one is creating nowadays a lot of discussions, and I think we will hear more in the later presentations. Also, various experience exists. Our estimation based on some measurements what we have done in the laboratory engines is that the NOx emissions are increased by 10 to 20% when using pure B100, so 100% biodiesel. And then there are various, of course, engine design plays a role, like a combustion process. Also, the raw material what is used in biodiesel results in different NOx emissions. Then it has to be noted that biodiesel contains about 13% less energy than petroleum diesel, so the consumption in volume basis is higher. Water separation is at least in some extent more challenging. It's working, but not maybe always at the same efficiency as from fossil diesel. Then you have to pay attention to the sealing materials and certain materials because the solvent characteristics may degrade those. The microbial activity, I would say the risk is bigger. We have seen in many places that the customers have not had any issues with the microbial growth, but that's something which shall be taken into account. Then also the long-term storage period is limited. So oxidation is taking place and an acid number is increasing if biodiesel is stored for too long time. We have seen some cases where cold flow properties have been an issue, but then I would say that it's been rather a quality problem in that specific batch than a general issue, because there are limits for cold flow properties in the standard. Then price, that is of course something which is influencing on customer decisions, whether they are interested in to use. And today the price is about double compared to fossil diesel. And if we think the whole need of marine industry, how much fuel is needed, production volumes are still low, and then there is also competition with other segments like automotive, for example. Here I have then one customer case from field, a Norwegian customer, United European Car Carriers. They have quite many vessels with Wärtsilä engines. So this is a vessel called Autosky, and it has two Wärtsilä 8L46 main engines. And the customer has used a good fuels product, MR100. And at the time of investigation, they had used it in both engines more than 3,000 service hours. Lube oil in the engine is a standard commercial, let's say, for 40B and 30 oil. I would say they could manage even with lower BN oil, but since this has not created any issues, they have continued the use. The vessel engines are going through scheduled maintenance regularly. When the biofuel use was investigated in more detail, then fuel injection equipment is obviously where we first see issues if something is seen, and then injectors were inspected then in more detail after the biofuel trial, but nothing abnormal was observed. The only negative thing what the customer indicated was that there has been some wax formation in the fuel leak pipes, and now they are planning to install trace heating to all leak pipes so that possible clogging and wax formation can be avoided. And the customer message based on the use was that they are happy with gather experience and are planning to continue biofuel operation on these engines. Then finally, the last slide where I have collected some future views. So as you obviously have heard, the marine fuel palette will be wide in the future. There are discussions about various carbon neutral and carbon free fuels, and our expectations is that biofuels will be a part of that palette, but what will be the share of each fuel and in which applications it's the optimum to use, that will be seen then in the future. Then about the greenhouse gas emission potential. There are various figures from 40 to 80% compared to fossil marine gas oil and heavy fuel oil, depending on the feedstock, what has been used and what kind of production processes have been used. And also what we have seen lately, that there have started to be blends of FAME and VLSFO on the market. Some companies are offering that. from those, our experience is still zero when talking about engines. We have had discussions and evaluation, but no experience from the engines. And then, of course, it's expected that the development will go further, and we will start to see third, even there are some statements about fourth generation biofuels, but anyway, that the crops like algae will be utilized, and those products can then come more common in the future when production volumes are coming bigger. And then this NOx issue, if there are biofuels, if there are engines where NOx emissions are higher than with fossil fuel, that the Einemo could solve that matter and allow the use. Because at the moment, the MAPOL Annex 6 Regulation 18 says that any fuel being not derived from petroleum refining is not allowed to cause increase of NOx. Only the heavy fuel is mentioned there, that there it's allowed to have a higher NOx than with marine gas oil being used in the EIAPP test. So that was what I prepared for this event. Thank you.
Thank you very much, Kai. Remco, are you ready?
Yes, I am.
Thank you very much.
Let's see if this works.
Yes, we can see it.
Yeah. Oh, that went a little bit too fast. Let me see if I can close the. So thank you, Kjeld, and I would like to thank you all for the opportunity to speak today. I'll be discussing the handling of biofuels on board, focusing on the fuel treatment systems such as the separator and the fuel conditioning systems, as well as the storage and further handling of biofuels in the tank. So let's start with the treatment on board. Now, the good news is biofuel is fuel. It needs to be conditioned by heating and pressurizing. It needs to be cleaned using separators and filters, and it should not be mixed with other fuels due to potential incompatibility. But since the introduction of the VLSFO fuels, ships have already been forced to pay much closer attention to fuel properties, and the fuel management plan does not need to be altered much to incorporate biofuels. Everything that Charlotte said was actually applicable. Temperature is the critical factor here. Treat the fuel too cold and you have to deal with cold flow problems. Too warm and the biofuel will degrade faster. And these points can lie quite close to one another. One other factor that directly affects biofuel properties in a negative way is the presence of water, as mentioned before. FAME is prone to bacterial contaminations that require to reproduce. Thus, removing water at all times reduces the amount of contamination over time. So to be clear, this needs to be done in all tanks, including bunker tanks. Actively check for the presence of water at all times. Water contamination leads in time to acidic products and sludge buildup with associated operational problems, such as filter and separation clogging or blockage of the fuel injector nozzles. Good housekeeping of biofuels is key. Dewatering and use the fuel as soon as possible. Now, as Dax and Kai mentioned, apart from storage and handling, since FAME is more corrosive than fuel oil, it is important that the equipment in the fuel line can handle it. Therefore, I recommend verifying with your suppliers that their equipment can handle FAME. For example, the internal coating of a viscosity meter, O-rings in the separator, a mechanical seal in the transfer pump can all potentially suffer from FAME and lead to equipment malfunction. So far, research and field tests have shown that for seals, gaskets, and O-rings, that phenomenon is not worse than for heavy fuel oil, but older equipment may not meet the expectations when using FAME. Also, consider the metals inside your equipment. FAME has oxidization properties that affects metals in one degree or another. And a couple of examples are shown here on the screen. But in general, using a fluid FAME for which the equipment is not specifically designed means verifying that the equipment will not suffer from its usage. The cold flow temperatures of FAME are dependent on the feedstock, relatively high. A short recap. Cold flow properties are noted from the lowest temperature up. So pour point is always the lowest cold flow property of a fuel, followed by the CFPP, and finally the cloud point, whereby pour point is the highest temperature a liquid is pumpable, CFPP is a quantitative measure for the amount of wax, and cloud point the highest temperature wax crystals will appear. Now, problems with waxing won't appear below the cloud point, so once this is known, I recommend to keep the fuel above this temperature. Trials are now carried out with mixtures of FAME and mineral oils with high blend ratios. And these are not only blends of FAME and distillates, but also of FAME and residual fuels. Cloud point and the CFPP are reliable minimum temperatures for distillate blends, but these temperatures cannot be determined with residual blends. So when encountering mixtures with heavy fuel oil, the WAT, the wax appearance temperature, is used instead. And I recommend to specify this test to be formed in the bunker analysis. However, the wax appearance temperature does not give an indication on the amount of wax produced, only the temperature at which it will occur. So for safety reasons, it is better to keep the temperature above the WAT. A special on heavy hydrotreated vegetable oil treatment in the separators. Fossil fuels, whether they are heavy fuel oil or diesel oil, typically do not have densities below 800 kilogram per cube. Separators are therefore typically not designed for the densities of HVO, which are specified as being between 770 and 790 kilogram per cube. This in turn creates some interesting problems that you need to be aware of. Purifiers running with a gravity disk typically do not have a gravity disk for these low densities. Running the separator will cause very bad separation efficiency. So if you start using HVO, I recommend to run the purifier as a clarifier, so without a water seal, or to request an HFO gravity disk if available. Automatic separators, such as the ALCAP separators from Alfa Laval, can handle HVO in a proper way, but I recommend to contact your separator supply for potential problems or for modified settings to optimize the running of the separator. All of these solutions are maker and model specific, so there is no uniform solution. Biofuel producers are actively testing their fuels in field test and in laboratory test. A test with BTL, biomass to liquid, will soon start in the Alfa Laval test center in Aalborg. Producers offer a large variety of their plants for testing, and it is relatively easy to test the fuels and reject those that, for example, produce a lot of sludge. Here you see a screenshot of a hot spin test. A hot spin test being a laboratory simulation of the behavior inside a separator. Thus, manufacturers can already reject those plants obviously not suitable for use on board of today's ships. And on a final note, Alfa Laval has published a white paper on the treatment of biofuels that can be found on our website. And that concludes my presentation for today. Thank you for your attention, and thank you, Kjeld, for letting me speak.
Thank you very much, Remco. And now we have Unni. Are you ready?
I am ready. Can you see my screen, Kjeld?
I see a small one.
Yeah, let me just do this and see if then that sorts it out.
That's good. Perfect.
Okay.
Yes.
Very
Thank
good.
you.
Yeah, we had a bit of trouble with this in the test, so good to see it's working. So first of all, thank you very much for having me, CIMAC. I'm really honored to be invited to your talks. It's such a great organization. So I'm going to talk a little bit about biofuel in relation to Knox and the MARPOL Annex 6 compliance. So let's see where does it sit within MARPOL Annex 6 actually. Now we all know that MARPOL Annex 6 sets limits for sulfur oxides and nitrous oxides for fuel oil for combustion purposes. But exactly what does this mean for the biofuel? Regulation 13 of Annex 6 sets out the limits for NOx, but compliance with the NOx limits is determined through the NOx technical code. And this is where it becomes very different from determining compliance with the sulfur limits. Because as you know, sulfur limits, we have the 0.1 sulfur limit in the emission control areas, and outside of emission control areas, the limit is 0.5% sulfur, and it's related to the sulfur in the fuel. If you're going to use exhaust gas cleaning systems, you need to prove equivalence with that sulfur limit. Knox is a little bit different. And as Kai alluded to in his presentation earlier, there's an issue here with regulation 18.3 of MARPOL Annex 6, which this talks about fuel oil quality, because it differentiates between in 18.3.1 blends of hydrocarbons derived from petroleum refining, i.e. your traditional bunkers, and 18.3.2 fuel oil for combustion purposes derived by methods other than petroleum refining. And of course, this is where you then get your biofuels and your biofuel blends and stuff which doesn't come from just refining crude oil in a refinery. And there's a caveat there that it shall not cause an engine to exceed the applicable NOx emission limits set forth in Regulation 13, which is where the limits are. So let's have a look at Regulation 13, NOx emission limits. There's different tiers for different ships. If your ship was constructed before 2000, there is no specified NOx limit because it wasn't developed yet. Then you have tier 2 for ships constructed on or after the 1st of January 2011. And you have a final tier 3 for ships constructed from the 1st of January 2016 onwards, when they are operating within a NOx emission control area. Because emission control areas, they can set limits for sulfur, which we know is 0.1. They can also set specific limits for ships' NOx emissions. And those emissions are significantly tighter in tier 3 than they are in the tier 2, which is applicable when ships are sailing globally outside of NOx ecos. And it only applies to ships constructed from 2016 onwards. So how do you demonstrate compliance with these emission limits, which are defined in gram per kilowatt hour? It's through survey and certification of the engine in accordance with the NOx technical code. And as Kai mentioned earlier, this leads you to obtain an Engine International Air Pollution Prevention certificate. And when you get that certificate for your engine, it's based on a specific test fuel oil, which is specified in the NOx code. And the test fuel oil has been defined as ISO 8217-2005 distillate marine grade. So typically, the engine test will be performed on a marine gas oil, for example. So the existing engine using a biofuel or a biofuel blend may then have to demonstrate compliance with that, because it's no longer just a fuel according to Regulation 18.1.3. So the problem we have here is, how do you prove that the engine does not exceed the applicable NOx emission limit when the certificate is based on a test running on DM grade oil-based fuel oil? It may, in fact, require onboard emission testing for fuel from non-petroleum sources, where the results could be presented in gram per kilowatt hours. Unfortunately, that's shown to be not particularly practical or reliable. You know, for ships that are using scrubbers or exhaust gas cleaning system for sulfur, they can have a continuous emission monitoring system. Would you require something similar for NOx? To my knowledge, that isn't particularly well developed right now, so there is an issue here with that. Is there a way forward? There have been some proposed solutions going all the way back to 2016, actually. One is to allow Regulation 18.3.1 to cover all fuel oils and delete Regulation 18.3.2, which then sets a sort of a specific mention of oils that are not from petroleum refining. And the reason IMRS came up with that was that they recognized that there was a problem with the language in the NOx code for introducing biofuel and biofuel blends. Then much more recently, there's been 2 papers actually put into MEPC 76. Now, because MEPC 76 was rather busy with other things, they didn't come up for discussion at the meeting that was happening very recently. But they are due to be considered at MEPC 77, which is due to take place in November this year. And one of these papers came from a group of countries: Denmark, France, Germany, Japan, Singapore, and ICS. And the crux of it is that they invite administration of parties to MARPOL Annex 6 to issue temporary exemptions for ships conducting biofuel trials for greenhouse gas reduction purposes. And there is already exemptions within MARPOL for example, for running emission control systems, such as exhaust gas cleaning systems, for example. So their approach is to encourage administrations to provide these kind of exemptions. Then there's an interesting paper also from India, which says consider amendments to MARPOL Annex 6 and the Knox Technical Code to clarify the regulatory requirement for use of biofuel and biofuel blends on board. And to me, the proposals within that paper are a little bit more similar to what IMARS proposed back in 2016. So there could be a way forward here. Now, biofuel, of course, why are we interested in it? It's clearly at the moment, it's not because it's cheaper, it's because of the emission reduction potential. So how does it compare to, for example, a distillate marine grade marine gas oil? We know that there's less sulfur emissions, but in fact, when you are burning it, it's quite similar in terms of the CO2 produced during combustion. And for NOx, as you heard from Kai earlier, there's some evidence that the NOx emissions might be higher, 10 to 20% for 100% biofuel, he mentioned, which is interesting. But of course, we're interested in it because of the significant potential for reducing carbon intensity if we are talking about fuel from a well-to-wake life cycle emission perspective. You're not talking tank to wake, you're not talking just about putting it in the engine and what comes out of the stack. At that stage, you're looking at the way that it could reduce overall well-to-wake emissions because of life cycle emission assessments. And this is where the IMO's initial greenhouse gas strategy comes in with an interesting point. It identifies among the candidate short-term measures, which are the ones which are being looked at first, to develop robust life cycle greenhouse gas / carbon intensity guidelines for all types of fuels in order to prepare for an implementation program for effective uptake of alternative low carbon and zero carbon fuels. So of course, it is there within the IMO's greenhouse gas strategy, and that might be helpful. Now, within that paper from India I told you about, it's quite interesting. It talks about an experiment with sea trials conducted on 2 ships. It went on for 3 months under all sea conditions in both loaded and ballast passages, so that all sorts of conditions could be covered. In order to run this analysis, they measured emissions at different engine loads with a certified flue gas analyzer and NOx analyzer in line with what's described in the NOx technical code. Now, they used 2 ships. One of them is certified for NOx Tier 1. The other one predates the NOx tier requirements. So they were clearly quite different ships. And so what they tested was a B20 biodiesel blend compared to a low sulfur, high sulfur, high-speed diesel, which was low, less than 1% sulfur. And for the first ship, the NOx Tier 1 ship, they saw approximately 2% reduction in NOx emissions. And for the older ship, it ranged from as little as 6 to as much as 28% reduction with this B20 blend compared to using oil fuel, high-speed diesel. And for the CO2, in both cases, they actually saw approximately 7% reduction compared to using the low sulfur high-speed diesel. And if you then took into account the life cycle assessment of the fuel, the bio blend that they used, the B100 of that had an approximately 7% reduction. And because it was a B20 blend, they could achieve a 21% reduction considering life cycle assessments. So this is why, of course, it's quite interesting. So to conclude this little look at this, is it's for sure that biofuel and biofuel blends can meet NOx emission limits. The same technologies that are used to reduce NOx emissions from existing engines can be used with biofuels as well. The question, it would appear, is how do you prove that compliance on an ongoing basis if you're not looking at changing MARPOL Annex 6. And there is growing recognition that the developments of low carbon and carbon neutral biofuels could be hindered by that current text of MARPOL Annex 6 and the NOx technical code. So is there a way around that? Well, MARPOL Annex 6 amendments, they take time. First of all, they require broad support at IMO, and they need to be taken forward under a new output under IMO procedures, and that's IMO speak for accepting a new item to be put on the agenda and add to the existing work programs. And that isn't taken lightly, since the IMO has a lot to do. However, considering that member states are now looking at this, and you have member states talking about putting forward a new output proposal, certainly that's in the paper from India, or indeed they might try to cover it on the IMO's initial greenhouse gas strategy. I think the appetite is there to actually do something about this. So that's what I had prepared in terms of looking at this. So now I guess we can go to the panel discussion. Thank you very much.
Thank you very much, Unni. Yes, we are going to the panel discussion. Yeah, everybody.
Yeah, I think actually that we would start where you left, Unni, because your presentation spiked some interesting question here. And there is one here regarding the reduction shown on the sea trial of B20. The question is, I guess also they made some changes on the engine, like the timing. Isn't it possible that the engine setting is due to the NOx reduction and not the fuel itself?
Well, I would have to read the paper in more detail. From what I understand, they ran the ships in similar conditions with both the biofuel blend and with the low sulfur diesel. So I'm not quite sure how they achieved those reductions. They seem to indicate that it's due to the fuel, and that otherwise conditions were identical. Now, one thing that I didn't mention during my presentation is that when it comes to the development of NOx as an emission, it seems to have less to do with the nitrogen in the fuel that you use and more to do with the combustion temperature being a determining factor in how much NOx is produced, which is one of the reasons why LNG, for example, is producing so little NOx.
Yeah, I think I would pass the question over to maybe you, Kjeld, because what is MAN doing on the two-stroke side to evaluate this NOx emissions from the biofuels?
Yeah, we are conducting a program actually in our research center where we are going to test different biofuels to see what components in the biofuel actually gives this extra NOx, if that is the case. So you could say to learn more about what is really happening when you are burning biofuels. And that we are doing for ourselves, but we are definitely also doing it for all the organizations, including Einemo, who is looking into it. We need a bigger knowledge base for this, and this is what we have started from our side.
I don't know, you already touched on the topic a little bit before. Do you have anything you want to add here from your side?
I think I can very much follow what Kjeld mentioned, what we are doing. So we have internal activities where we are investigating why the NOx is higher, and then also, let's say, the discussion go into that direction, that Einemo will start to discuss it and make a decision, and of course expecting and wishing that it will be positive, like Unni indicated in her presentation. The higher NOx, how we see that at least one contributing factor is the oxygen content of FAME. So we don't see increase of NOx when running on hydrotreated vegetable oil, which does not contain any oxygen, or very low amount. But in FAME it's around 10%. And fuel nitrogen, that influence I see is very small. It's the thermal NOx which is happening during the combustion process, which is influencing on NOx formation.
Max, I have a question for you here that came in. How about marine biofuel that's extracted from lignin? Have you explored that at all?
To be very frank, it has not been discussed yet. But of course, we're aware that that's one of the fuels that's currently being researched, but is for sure not ready to be standardized, because I think the formulation has not been finalized yet. So it will fall into a second stream where we have to prepare the standard to be able to accommodate these kind of fuels, but it will take more work to be able to do that.
When do you think it will happen? I think that is probably one of the big questions in the industry.
So I think so. If you recall what's happening in other industries, right, which I think is the best guideline for us, because we're lacking behind a little bit, is that you see they take each individual process, feedstock, evaluate that, and then include that in some sort of specification and use. And I think if we want to achieve goals that we set out for each other in saying, okay, we're going to reduce our CO2 emissions, or to chip in a little bit, Unni was saying, to change our life cycle, shorten it, and making it with better use of raw materials. I think anything is on the table and will be used. It's going to be a big variety of different materials.
Yeah, I saw a quite interesting question coming in here as well. How to deal with the low flashpoint biofuels which are not compliant with SOLAS regulations? I'm not quite sure who would deal with that one. Maybe also for you, Dax.
I'm getting a little bit out of my comfort zone, but of course, I think there's two things about this. It belongs with the SOLAS, and that brings back to Aabo. So yeah, I give it to Unni pretty quickly. And I think it has to do on a case-by-case basis on ship's design, and then also regulation around the fuel itself. But I hand it over to Unni there.
Sure. Now, in terms of low flashpoint biofuels, I think the first thing to say is I'm not sure that we have them. I don't think flashpoint is a problem with biofuel, but if there is a flashpoint of a fuel which is below 60 degrees, which is the SOLAS limit, then they need to be dealt with under the IGF code. So all fuels, even all fuels, like for example, if you have a marine gas oil that falls below 0.60, it's not SOLAS compliant, and you would need to meet the IGF code requirements in order to use that fuel. And if you look at the IGF code, it's written really with LNG in mind. We've had already a chapter or guidelines added for methanol, which sort of somewhere in between LNG and traditional fuels, but basically for any fuel that falls below 60, it needs to be under the IGF code. So that's where that sits. And one of the things that the IBIA is working on is developing guidelines for low flash oil fuels, and I don't see why the biodiesel wouldn't sit within the same chapter when that eventually is done.
Yeah, maybe I could add that Unni, you mentioned methanol, and we have the first engine burning methanol already in 2016, and that was before the IGF and IDC codes and so on. It just came in December last year, I think. So at that time it was approved. These hazard investigations was the basis for the flag states and the classification societies to accept that it is operated without the code is actually enforced. So I would assume that it will also, for low flashpoint biofuels, we will need to have a hazards investigation, and based on that also a fuel gas supply system, which for instance have a double wall piping when you go into engine room and so on.
Maybe I can add a little thing. If I think about this question, I know that HVO in the EN 590 standard has a flash point of 55 degrees, so that might be where this question originated from. But that doesn't mean that you cannot specify when you order HVO that it is above 60. I mean, the minimum production is 55, but for ship use we want it to be above 60, and you verify that with a test. Then you can easily say that it is above 60, so then you can use it. So just specify the flash point as being outside of the 590, just 5 degrees above, and verify that with the test.
Yeah.
This is exactly what we are doing as well, what Remco says, and when the HVO is used a lot in land-based applications in automotive, then there has not been any need to put 55, but when I have been discussing with some suppliers, they say that it will be above 60, so in the spec it's 55, and we have just stated when there have been questions that the end user shall request that the flash point or delivered fuel patch is then above 60, and I have not seen any or heard any issues that it would have not been so.
We have a question here, and I'll read it out, and whoever thinks you want to give it a go, please chip in. Do you think the biofuels will represent the future of marine fuels? The ongoing decarbonization process requires much lower reductions in carbon emissions. There is a sense to invest on these fuels rather than other sources, like, for instance, nitrogen. Remco?
Yeah, I can give it a start at the very least. I mean, the major advantage of the biofuels is the drop-in status. So in the ongoing decarbonization and the use of the ships currently in the fleets and the ships that are still being built that are running on fuel oil, biofuels can definitely lend a very good hand. And I mean, these ships will be long in the future, will still exist, so they are going to be a part of the decarbonization. But that doesn't mean it's the only path, and we need other initiatives as well that go into other fuels that are renewable produced, like the methanol, ammonia, hydrogen, all the alternative fuels that are on the table, but that are not developed yet. But the advantage of biofuel is available today. It can help you with your greenhouse reductions today and in the oncoming 10 years for sure.
Yeah, I would echo what Remco just said. The attractiveness of biofuels is that they offer a pathway to reducing CO2 emissions overall, considering that life cycle emissions are taken into account. That's available.
Yeah, they do that, but also they, you could say, if you look at our engines, dual fuel engines, where you use a pilot oil to ignite the low you can say the low flashpoint fuels, then biofuel could be one source, which will actually make the total emission from that engine, both for the main fuel and the pilot oil, and lower the CO2 and greenhouse gas in that way. That will be smaller portions, but that would be a way to do it.
Exactly. Now, the attractiveness is that it's sort of quite readily for use in existing ships, and there's a lot of them around. Let's face it, you know, they don't all have dual fuel LNG engines and systems installed. So that is the attraction. Of course, longer term, there's other solutions being looked at, and there's a lot of interest in hydrogen in particular, and with ammonia as a hydrogen carrier, because it gives you no CO2 emissions from the ship. But it's again about the production of green ammonia or green hydrogen, which is the barrier at the moment, because even if you don't get emissions from the ship at the moment, the amount of green hydrogen available in the world right now wouldn't cover very much of shipping's demand. But
I think that's the key, that you need to have diversity to be able to fulfill that energy need that you have globally. It's not only shipping, but it's also other energy sources that you need. So I think it will be part. It will not for sure not be the solution, but it will maybe solve somewhere between 10 to 20% of the energy need for shipping. At least that was in the predictions of the energy agency.
What do you think would be the major incentive to lead to the industry to use more biofuels? Will it be regulatory policies or public opinion or something else?
If I should start, I would say that we hear customers that have their goods transported who would like to do it in a more green way and then drop in biofuel in normal, very low sulfur fuel oil is seen to one step in that direction. And that interest, of course, also encourage the use of such biofuels.
I mean, if we look today, there is no regulatory framework around this. So there is no real true regulatory. So what's driving it today is basically society and customers, I think. Is that the best way to go about it? I don't think so. I think there's more needed to actually incentivize and actually to level playing field the whole market, actually where you say, okay, the CO2 reducing fuel is more competitive towards a fossil fuel. And I think that's something that people need to consider to actually kickstart and further develop this initiatives.
You're quite right, Dax. I mean, at the moment, you have front runners who are taking on voluntarily demonstrating new lower carbon fuels because they want to be front runners and they want to be ahead of the game. But the regulations will come. You know, I mean, you have the public opinion on one side, but the stick in form of regulations will increasingly come in and of course, going forward at the IMO, the shape of that stick is what's being developed right now.
Going back a little bit to you, Remco, and slightly off the regulatory regime, question came in. How can you recommend to keep fuels above the wax appearance temperature at all times? Doesn't that invite thermal breakdown?
It does, and that's actually a very valid question, and that is that balance of heating versus keeping your fuel cool. I mean, I try to put in a simple way to safely treat the fuel, but it definitely doesn't cover all. The thing is with the wax appearance temperatures that you do not have control over the wax. I mean, I've seen examples of a wax appearance temperature of 80 degrees Celsius. If you transport it at 20 degrees Celsius before using it, you have no idea how much wax is in the tank, and if you can heat it up sufficiently in order for it to be pumped into your systems, or if the wax crystals disappear. 80 is of course an extreme example. But you need to really start thinking about, if you see this, how am I going to treat it? And it's an indication that there is something going on, and that you need to. I mean, if I would see as a ship owner, I would see this, I would say, okay, I want more test maybe the wax disappearance temperature, so the temperature which all waxes have disappeared. Okay, if I know that, say it's 10 degrees higher, then I wouldn't have so much problem. I have a watt of 40 and a wax disappearance temperature of 50. Okay, I can just leave it in the tank and heat it up to 50 degrees before pumping it, and I have no issue. But it isn't, it's an interesting question, and we haven't come to the end of it. For now, there's a lot of people who are doing their trials and approach suppliers. I can only encourage more to do so. We need a lot more investigation in this topic. I admit it was an easy way out for me to just say, yeah, keep it above wax appearance temperature to make sure you don't have any wax crystals. But clocked fuel tanks are not fun either.
I think I would pass it over to you, Dax. How would you feel about all your ships heating it to the fuel to above the wax appearance temperature?
I think we need to be a little bit more realistic about this as well, because don't forget, if you look at the overall efficiency and you have to keep all your fuel heated, I mean, that's going to cost an enormous amount of energy. And I think that is not the way forward in my book. So I would really look into, okay, quantifying it, look at the wax disappearance temperature, and actually look, okay, how do you actually, what time do you need to reheat the fuel before you start using it again, if that's possible. Again, I think heating, keeping the fuel of the worldwide fleet at a certain temperature is not the way forward in my book, in my humble opinion.
Unni, back to you. Here's one for you. Shall we get more clarity about biofuels regulatory aspect during MEPC 77?
Maybe. The thing is, these two papers that I mentioned, which were submitted to 76, and so many things that were meant to happen at 76 have been deferred. These were actually not even up for discussion. They were deferred in advance of MEPC 76. So it depends a lot on the nature of discussions during that meeting, because the whole greenhouse gas policy area is so fraught that they take up a lot of time. But they have been put forward. They are meant to come up at 77. Hopefully they are dealt with, which would mean that we would begin to see a path forward about whether it comes as a new output to make amendments to MOPL Annex 6, or whether somehow it can be considered to be already on the agenda because of the initial greenhouse gas strategy, which might help accelerate the way forward. But I'm really hoping that it would come up at 77, so that we can begin to see the way forward on how this might be handled.
Yeah, I think we are coming to an end of the discussion, but I just have one final question leading into more into the future, I think, for Kai and Kjeld and the rest of the panel, if you'd like to chip in as well. What kind of other several fuels are actually investigated? For example, is it ammonia, methanol, LNG? What is trending in the industry?
Should I start, Kai?
Yeah, please.
Okay. I would say that from our side, on the two-stroke side, the market tells us that ammonia is a very interesting fuel. We do a lot of presentations about coming ammonia engine that we are designing, and we are heading for an ammonia burning engine on testbed, ready to go to a shipyard in 2024. So that will be another, you can say, dual fuel engine to our portfolio. Methanol also is increasing, interesting, LPG also, but then again, are we speaking about in 2040, 50, or are we talking about this transient period of time where you can say step by step lower the CO2 and the greenhouse gas footprint?
Kai, do you want to pick up or?
Yeah, okay, yes, I can say something. Of course, if LNG was mentioned there, of course, that has been a common fuel already for decades, though not achieved yet so big popularity. But there, of course, when there is more bio LNG available or synthetic methane, that's again then reducing greenhouse gas emissions. And then we have sold some engines being operated on liquid ethane gas and liquefied propane gas. So gases are clean fuels and so not always influencing significantly on greenhouse gas emissions, but the local air quality is anyway influenced a lot when you are burning clean fuels. And then this, I would say that these three other fuels, methanol, ammonia, hydrogen, those are all creating a hype depending on with whom you are discussing. So some are fond of ammonia, some are talking about the hydrogens, some are considering methanol, and this is, I think, how it will be in the future, that there will not be only one one fuel with big share, but depending on the applications and where the ships are sailing and availability and logistics, that which fuels are preferred. But when talking about all those, then of course the main thing is that those are then green fuels. It's if it's like ammonia today or methanol today made from natural gas or coal, that does not make much sense. So need to be green fuels that we will have the influence on greenhouse emissions.
If I can just take it back to that point, it's exactly that, Kai. It's about the life cycle assessment that needs to be taken into account here. Because you can even with biofuels, you have some biofuels which are great if they come from waste products, and then you have others which are dubious, both in terms of where the feedstock comes from and the production methods are actually creating quite a lot of CO2. So they're not created equal. And when it comes to methanol, as you mentioned, if it's produced from natural gas, you're not gaining anything. But if it's produced from biosources, it's good. And of course, the ship engine doesn't know the difference. So for the ship, from a practical ship engine perspective, it doesn't matter. So it's what happens before it comes to that stage that matters. And another thing that we haven't spoken about so much, of course, is the costs. The cost signals. It's very difficult because we know already that what's the cost of something today. It doesn't necessarily reflect how much more or less it's going to cost compared to oil fuels today. So it is a challenging time going forward. But for me, it's the life cycle assessment and the potential costs going forward that will be the crucial factors.
With this, I think we will say thank you for this interesting discussion, and I will leave you to pick that up, Kjeld.
Okay, thank you very much, Charlotte. I would like to thank the panelists very much for the presentations, the discussions. To the audience also, hope that you really enjoyed it as much as we did, for the question and participation. And if there's any question, do please write to us in CIMAC, and we will follow up. So thank you very much and have a nice day.